You know, the next big thing in technology might not be a shiny new gadget or a killer app. It might just be a material. Today, we're diving into a really cool breakthrough that could completely change the game for the future of computing.
So let's start with something you've probably noticed. Think about your laptop getting warm on your lap, or the sound of those fans whirring away inside your desktop. Have you ever stopped to ask, why do they do that?
Well, the answer is actually pretty simple. It all comes down to wasted energy. You see, every single time electricity zips through a wire, a little bit of its energy just gets lost along the way.
And that lost energy has to go somewhere, right? It doesn't just disappear. It turns into heat. And frankly, getting rid of all that waste heat is one of the biggest headaches for just about all of our modern electronics.
So what's the fix for this massive energy leak? Well, for decades now, scientists have known about what seems like a perfect, almost magical solution. And that solution is called a superconductor. This is a special kind of material where electricity can just flow with absolutely zero resistance. I mean, think of it like a perfectly frictionless highway for electrons. Zero resistance means zero energy gets wasted as heat. It is, for all intents and purposes, a perfect wire. Now that sounds like the ultimate fix for our hot, power-hungry computers, doesn't it? Well, there's a catch.
And that catch-all comes down to a really, really crucial difference. The difference between just moving electricity and moving information.
What happens when you need to do more than just send power from point A to point B? This is the core problem we face when trying to build things like quantum computers. They don't just need electricity, they need to send data in a totally new way.
You see, these conventional superconductors, they're amazing at carrying an electrical current. I mean, perfect, right? But they completely fail when it comes to carrying this other, special kind of quantum data called spin.
So what on earth is spin? Well, think of it this way. At the tiniest quantum level, every electron has this property that acts just like a tiny compass. It can point up or it can point down. And that's a perfect way to represent the zeros and ones of digital information.
And that right there, that's the holy grail. To build the incredibly powerful, super efficient quantum computers we dream about, we need one single material that can act as a perfect highway for electricity and a perfect highway for the spin information, all at the same time.
And this is where the hero of our story comes in. We're finally looking at a new class of material that just might be able to pull it off.
This new class is called a triplet superconductor. And unlike its classic cousins, it seems to be designed from the ground up to carry both that electrical current and that super important spin information, flawlessly with no loss.
And the most exciting candidate in this new category that scientists are looking at right now is a metallic mix called NbRe. That's just short for niobium and rhenium.
So what is this stuff? Well, when you combine these two metals and you cool them way, way down, they start to show these really unique properties that scientists have been hunting for. They behave in a way that is totally different from a classic superconductor, showing all the signs of being one of these rare triplet materials.
Now, for this magic to happen, NbRe has to be cooled to an incredibly chilly -266 degrees Celsius.
I know what you're thinking. That sounds absolutely freezing, and it is. But here's the funny thing. In the wild world of quantum physics, that's actually considered kind of warm. It's a much easier temperature to work with than what a lot of other experimental materials need, which is a huge deal because it makes it so much easier for scientists to actually study it.
So, let's bring it all together. What does this actually mean for the future? Well, if NbRe really is what we think it is, it's not just some lab curiosity. It could be the key that unlocks a whole new age of technology.
I mean, the potential here is just staggering. We're talking about quantum computing, which could solve problems that are literally impossible for today's best supercomputers. And we're also talking about a whole new field called spintronics, which could use this spin property to make all our electronics way more powerful and efficient.
And the end result of all of this? It's a clear path forward, a path toward building quantum machines that are not only way more powerful, but also way more stable and energy efficient, all because you're moving both power and data perfectly without any waste.
So let's just recap why this is so huge. You've got a material that moves electricity with zero energy loss. And crucially, it can also carry that spin information at the exact same time. That combination is the secret sauce we've been missing to build the stable and efficient quantum computers of the future.
Now, the research is still pretty new, but it leaves us with this incredible question. After decades of searching, Could this simple mixture of niobium and rhenium actually be the fundamental building block for the world of tomorrow?